we just
Is
need more
induction?
Oh, this is so nasty.
Really?
No.
Can you please rinse that off?
Okay.
Is induction? Magnets?
So I have a magnet here,
Because there's a.
and I'm going to attach it to a little arm. This is just steel. Do. So now it's a magnet attached to steel.
Was the steel not a magnet before?
Not really, no. But obviously I can't pick things up with my electromagnet, so it's hard to convince you. I need to get some paper clips and show you stuff that works. All right, I'm going to plunge the magnet into the coil. Watch the meter.
Whoa, it just cranked.
Did you see that? Which way did it go? And then the spring action brought it back a little farther, but it stopped. Magnet's still in there.
You have to move it.
And this bothered Faraday.
Oh.
He's like, okay, I got a magnetic field in there. I definitely got a magnetic field in there. Why isn't the current continuing? Pull the magnet back out.
It went the other way.
And it went the opposite way. Oops, missed. Okay, what happens if I go slowly?
Oh.
What do you notice?
It's more
If I
continuous.
come out slowly.
I think it's like the same thing like when we shot the paperclip.
What are you referring to? Go ahead.
Like when you just tapped it, it had the most charge when it was like far away from the middle. And then once it got to the middle, like slowed down and it would get stuck in there if you
Oh.
left it connected.
Interesting.
When you shower, or is it like for time or something?
So
That's-
what an
Friday?
electric generator does is it goes, it doesn't get stuck on the sides like that. Okay? And it generates current that goes one way, then the other way, then one way, then the other way. But it can't just create a steady current in one direction, can it?
Wait.
Alternating.
Yeah.
What if you took like a tube of those things, like in a ring, and then made something to run in one direction? 'Cause then you could.
Each different little section would have current go one way, and then as the magnet went by, current go the other way. And I'd be doing that all the way around. One way, over here, one way, the other way. They'd be out of sync a little bit, right? They wouldn't all be in sync together. But yeah. That's what his thing did when he turned the crank on his metal wheel. He was creating something called eddy currents in the metal. And those things were creating a resulting flow of charge in their vicinity that then would switch and go the other way. And he was picking it up just like we're picking it up. Okay? But he kept it going by turning it in a wheel. Everybody okay so far? That's induction. Inducing a current by using a changing magnetic field. Note changing magnetic field. It's got to be changing. It can't be a constant magnetic field. Yes?
What are the units of that? This is your amp is measuring.
Milliamperes.
Okay, gotcha.
Yes.
Wait, so could you repeat that? Inducing a current by
By changing the magnetic field in a loop. Everybody good so far?
Does it have to be in a loop?
I could do it along a straight wire, it just wouldn't have the same effect. By using loops that go around themselves, I magnify the effect. Every loop experiences the same thing, and it just multiplies. Or adds.
Yeah.
Yes?
So maybe this could be off topic, but do you have induction for heat too?
For what? For heat?
Yeah.
Are you thinking of an induction stove?
Yeah.
Now,
Well, but
how many of you have an induction stove at home?
I don't know what that is.
We have an induction stove. They are a miraculous device.
Okay.
And what they do is they change the magnetic field underneath your pan. Now, if you have aluminum pan or a copper pan, it doesn't work. But if you've got a cast iron or a steel pan, stainless steel pan, that's ferromagnetic. And as the magnetic field changes quickly, electricity begins to flow one way, then the other way, then the other way, then the other way. And what does current do through a resistor?
Well, it heats it up.
Creates power, creates heat. And it will actually heat up the pan without transferring heat from the burner to the pan, just by making the molecules in the pan move back and forth and create current.
The heat, I mean, is the pan that is heating, like there is.
The pan is heating,
Wow.
yeah.
Is it?
But
So,
the
because
thing is
then-
not.
So if you lift it up and you touch it with your hand,
The
Because
heat
another-
may have transferred back down a little bit to the ceramic, but no, it should be cool.
Black
Wait,
magic.
cool.
You could put a piece of paper between them and it'll work
And it
just
will-
great.
Does anyone have one
Is
of these
it?
that we
Is
can
it
play
more
with?
efficient?
I don't know about that. Some people will say yes because you're only heating the pan, you're not heating the air around the pan.
But the process itself might be more.
Yeah, converting the electricity to a changing magnetic field to get it to turn into heat. I'm not sure if that is more efficient than turning the gas into fire to create your heat.
And also because electricity has to be made.
Everybody good with this induction process? Now, technically, it's not just changing magnetic fields, it's changing the magnetic flux.
Yeah.
I could change the area through which the magnetic field goes and get the same effect.
Just smaller or bigger area.
I can actually just move this across the top and get an effect. So moving it all? Okay, it didn't actually have to go through, it's just not as efficient because I didn't go all the way through the coils.
What if you do it outside?
Yeah, that's what I was gonna ask.
Up and down?
Or whatever.
Oh,
Tiny effect, it's changing the flux in there. Right, going sideways. Tiny. It's changing the magnetic field inside, so it's creating a little current. All right, now, his last big invention
Is for holding.
was something we call a transformer.
What does it transform?
Transforms into a car.
All right, I'm gonna add this iron core to magnify the effect. This bothered him at first. This was a part of what was bothering him.
It seems like he was bothered by it.
He was bothered. He was a bothered, troubled man.
I thought your battery didn't work.
All right, I don't know if it does or not. Let's see if it sparks. Oh, it doesn't spark if it falls off.
Don't shock yourself.
Too late.
No.
It's only 12 volts, man.
that you.
Is
Did
that-
you shock yourself?
No. It's not really making much of a spark. It should be making a spark.
I feel like we just need to hook up a whole bunch of batteries.
Oh, this may explain many things.
Was it?
I have a bad connection to my battery. Oh yeah, I should be getting good sparks there and I'm not. So bad connection. Ah, we're cooking with gas. All right, here we go.
Connection, you mean they were not attached to the wall?
The terminals weren't making good connection to the battery. So again, he expected magnetic fields to create current, just like current creates a steady magnetic field. He had to change his mind about that. If I could just clip that on there, it'd be so much better. Let's try the other side
No
first.
dualism, whatever.
All right, so watch the meter. I touch this on there. Anything happen?
No. Oh, yeah.
Oh,
There's a spark.
If I hold it on there,
It should stay with
it jumps to one side, but when I take it back off, oh, I must have slipped off already.
No, it did jump to the other.
Here we go, coming off.
Oh, those sparks.
Here we go, coming off. Just came off. It only happens when you change the current.
Wait, so if you had current that went back and forth really, really fast,
Then would it have
Then it would work great.
plug it into the outlet.
Faraday didn't have outlets.
It dumb.
He had the big motor
Okay.
downstairs though, right?
Yeah,
You had the big battery down there.
That's
Oh, yeah.
basically an outlet.
You said the big motor. It's only-
Alright, so what you just saw me do was create a voltage in a secondary coil by changing the current in the primary coil. Now I can do that with a much bigger coil.
Do we?
Don't do it, Mr. Bass. Don't do it. Save yourself, Mr. Bass. Alright, this is a bigger coil.
That's a microwave.
Yes, this is the transformer from a microwave oven.
Isn't that dangerous?
Does it scare
It
the
can be.
acids, you know?
If I hook it up to alternating current.
Can we do that?
No, not right now.
Really?
We're talking about Faraday. Come
I'm sure
on.
Faraday would want us to do
Yay,
this.
Faraday
Faraday
Day.
would want us to mess
Faraday
with
All right, so I want you to
Faraday's
notice something.
Farah today.
I'm going to touch this to the other side of a big coil. And then I'm going to remove it. Something surprising happens.
Really?
Does it explode?
Here, they're just touching each other. Oh, there's no sparks there. Did you see sparks?
No.
Need better contact.
So what is this yellow thing again?
There.
Ooh.
It's robots and.
All right.
Those are nice.
I'm going to touch it to this wire. Did you see a spark when I lifted it off?
Yeah.
I actually saw it starting to glow hot.
Oh, whoa.
Oh,
I don't know.
that was a nice
Whoa.
one.